So moving on to the next presenter of the day, we have, and I apologize in advance because I'm gonna mispronunciate the names, Andre Renato, Farid, Vahdati, Sergey Miller, and Andre Dore, presenting integrating VR and simulation for enhanced planning of asphalt compaction. What is yours? Please.
Right.
15 minutes.
I'll try. I'll do my best. Thank you very much for the introduction. So my name is Farid Vahdati. I'm from the University of Twente in the Netherlands. And I would like to talk about the small development that we had within our research unit, Aspari. And the whole idea was to develop a planning tool that could be used by the planning crew of the pavement operations. So before I start with the core technical detail of what we developed, just to give you a little bit of background how we got to this point. I'm coming from a research network called Aspari, and we believe that this Aspari network is quite unique, mainly because about 10 or 15 years ago, the Dutch government had decided that the entire contractual scheme for pavement operations should change to performance-based, and they start to put this high guarantee requirement from the contractors. And what happened at that point is that contractors, all of them together, collectively decided to support a research initiative that could help all of them to improve their operation. Because the argument was that from the material perspective, we have quite a bit of knowledge, but we don't know much about how the construction operation should take place when it comes to pavement operation. So what happened is that we are working with 10 major contractors of paving projects in the Netherlands. Collectively, they account for about 80% of asphalt projects in the Netherlands. So the entire research that we do within this Aspiring network is sponsored by all these contractors. And because they are the main beneficiary of whatever we do, we basically co-produce solutions for them. And we have most of the research that we do, it's really user engaged. And we always try to get the requirements and practical demands from these contractors, and whatever we develop is later on validated by them. So it's a very unique ecosystem in that respect. So what we did, because in order to improve this operation aspect of the paving operations, we've been developing a lot of operator support systems. We have similar things for excavators, for cranes. So basically, if I want to simplify, we were trying to develop these navigation systems that could be placed in the compactors and help operators to better understand what is the best compaction strategy. So we've been doing that for the past 6-7 years. And about 3 years ago, we noticed, no matter what you do, no matter what you develop, the adoption is extremely low. And there are many different reasons for that. I'm not going to get into that detail. And that's when we noticed that maybe the bottleneck is in the education and being able to build trust among the operators that these technologies could actually help you and not necessarily replace you. So about 3 years ago, we started developing this training simulator, which is kind of unique also in nature. And why I call it unique, because it's not a hypothetical scenario that we build in Unity and then ask operators to follow that. Because prior to that, we've been collecting a lot of data from the actual paving operations. We developed a simulator that works based on the data that we collected from the site. So basically, you look at the data, you translate this data into a context-realistic training scene, and then you immerse the new operators or trainees into these context-realistic simulators that are built based on the actual projects. So because there is a very interesting connection between the actual data, the simulator, the VR platform, and the practice, we've been also quite lucky to implement this in Soma College, which is the largest construction training school in the Netherlands. And they actually provided us with the infrastructure that they had. Now we have 4 fully functional training simulators in Soma that we actually installed our simulator on. So we did this training. It was well received by the contractors. They actually keep asking us to have these training sessions with their operators. So it was everything seemed quite okay. We had some fantastic results with that. But then going forward, we noticed it's not only about training. we've been trying to tell these operators that, hey, when you start the project, you need to be aware of some of the very critical information that you need about the asphalt. Like if you have a certain mix, you need to know for that specific project how many compaction passes you need, and for that specific mix in that weather condition, what is the appropriate temperature window that you need to take into account for the compaction operation. And well, when you talk to R&D experts of the companies, they know this information. But go to the site and talk to the operators, they never have this information. They always go back and rely on their craftsmanship and their tradition and their intuition. So they never actually know what's the appropriate temperature for that specific mix. They just look at the asphalt, and from the trace of the roller, then they would say whether or not this compaction is good enough. So from the theory perspective, the knowledge is there, but when it comes to application, it's never there. And this leads to operational variability that ultimately translate to inconsistent quality. And we deal with that on a daily basis. So then we trace back the problem actually to the planning. We talked to these paving planners, and we noticed that they normally have a planner sitting in the office trying to decide what would be the best logistic strategy for this particular project. So they come up with the required number of trucks, the best asphalt plan for that specific project, and in what frequency the trucks need to be sent off. But then they never actually go to that tactical level of deciding, okay, on the site, boot on the ground, how many rollers do you need, and how these rollers need to collaborate with one another? Do they need to do it in parallel, in sequence? Well, how many passes is required for the breakdown compaction and then for the ultimate compaction? These things, the planners actually never decide, and they leave it to the operators and the construction crew on site. So it creates a kind of disconnect between the logistic planning, or what I call the strategic planning, and more tactical planning, which is done on site. And this fragmented modeling approach makes actually push planners to ignore the intricate interplay between the strategic and tactical planning, because they are extremely correlated. So then we went back actually to what we developed in terms of the VR training. And because it had a good connection with the data, we developed that vision that, hey, maybe we can expand the use of this virtual reality-based training and use it also for project planning. We also use it for technology prototyping and project review, but I'm not going to talk about it. But the idea that we developed is that maybe the same simulator could be leveraged for project planning. And that was the idea that we tried to explore and pursue in this specific research. So with that objective in mind, the first thing we did, we had quite a bit of interviews with the planners, the strategic planners, but also the paving crew on the site who are mostly responsible for tactical planning. And we tried to identify what are those core decision-making parameters that they need to consider or take into account to develop a proper planning, both from the strategic perspective and tactical perspective. So we develop a whole list of parameters. Some of them are fixed. So you actually, for a specific type of project, like the geometry of the road, the layer thickness, these are the things that you know. But there are certain parameters that you need to decide as a decision maker. So we identified all those decision parameters through interviews with the actual planners. And then we moved on to develop our VR-based planning tool. So the way that this platform works, first we develop an agent-based simulation in AnyLogic that represents the compaction process in a rather generic way. And we develop an interface that would allow the planners to put all the information that they know about the project into that interface. The interface is connected to our AnyLogic simulation, agent-based simulation. It generates all the temporal data, which basically says how the equipment moves at what time period. And then that information is passed on to our virtual reality platform that mimics from the temporal perspective, it receives all the time data and then try to generate the visualization of that process. I will tell you later why this visualization becomes quite interesting and important. So this is the interface that we developed. One of the things that is quite interesting, because in terms of proper compaction, the cooling curve of the asphalt is quite important. How asphalt cools down, and that of course depends on the layer thickness, the base layer that you have, the weather condition, etc., etc. So in many cases, the planners actually do not have that idea. So what we did, because our planning tool was rather flexible, we gave them the option to choose from the database of the past projects. So they could look at projects with more or less similar characteristics, and then opt for a cooling curve that is actually collected or built based on the actual data. And then, just for the sake of argument, we came up with 4 different compaction strategies, or basically how these different rollers could collaborate and cooperatively perform the compaction. That's also quite interesting. We've been trying to find a kind of formal definition of these compaction strategies. Doesn't exist. There are a few textbooks explain something, but most of this knowledge is quite implicit in the mind of operators. So we have some ideas how we could extract that quite nicely, but for now, we just resorted to one of the textbook, quite old one, that we found they had these 4 strategies, and we tried to mimic those strategies and then give the planner the option to choose among those 4. And then we had this agent-based model developed in any logic. It's connected to the interface, it receives all the data, and it generates also a 2D view of the asphalt operation, but without any geometry. So the road is considered as a linear rectangle. And then the result is passed on to Excel, and then or Unity is connected to Excel, so it could read all the data and then visualize the same process in 3D. But the interesting thing is that because of the 3D visualization, now we could do a lot of interesting analytics with the asphalt. So one of the things that we actually, this is an index that we defined ourselves because it actually didn't exist in literature. And we define it as compaction efficiency. And basically compaction efficiency says, if I'm going to discretize the entire road into cells, I would like to know what percentage of these cells have received proper number of compaction in the right temperature window. So if let's say, for example, the required number of compaction paths was 5, and you had the 5 compaction, but it was 1 of them or 2 of them was outside the window, then you do not consider it as properly or effectively compacted. So we defined this index, and then within that simulator, because our infrastructure was also based on rasterized cell of the pavement, it was very easy to actually predict the potential compaction efficiency for that specific planning. So I have a small video of this development that my student did, but it's going to be quite long. Well, it's 2 minutes, but you don't have to see it. So basically, you define the project, you input all the variables that you need to do. You need to pass on to the simulator, and then you run any logic which is directly connected actually to that interface. So you could actually speed up this process. It's not supposed to be as slow. And then once the simulation is finished, then basically you could immediately from the same interface run your virtual reality representation of the same operation. And then based on the compaction strategy that you have opted for, these 2 rollers start to move. And then once it's finished, then you will get all the data analytics indexes that you require about the quality of the work that was implemented. So for the validation, of course, 2 aspects were quite important for us. One was about the accuracy of the simulation model that we developed. So we had quite a bit of past project, so that was quite easy for us. In here, I'm just presenting one of the cases, but in the actual project, I guess Andre did 5 or 6 different projects. The error rate is more or less in the same range. So as you can see, for most of the indicators, the error rate is quite acceptable. The compaction efficiency, not so much because, well, in the strategies that we developed for these rollers, they move in a very controlled way, but then operators, the actual operators on the site, there's quite a bit of uncertainties about how they perform compaction, and that creates quite a bit of misalignment between the predicted and actual compaction efficiency. And then, of course, we went back to the planners. We asked them, okay, this is how you actually do the planning. And what do you think about the platform that we developed? So we asked them to do the entire planning using this platform. What they actually liked the most, and most of them highlighted, is that as a strategic planner, I was not aware of those parameters that are important from a tactical perspective. And I did not know how my decisions would impact on the tactical planning of the crew on the site, and vice versa. So they really appreciated the awareness that this tool would provide them in terms of the complexity of the entire planning process for the paving operation. So with that, I would like to conclude this presentation. We noticed that, well, it's quite insightful, not necessarily from the accuracy perspective, but also just in order to demonstrate the complexity of this process. The planning crew actually appreciated this tool quite a lot. They appreciated the fact that this is a multi-layered decision-making and you can perform it in one single platform. And also the ability of the model to make tactical and strategic planners aware of the intricate interplay between layers of decision-making. For us, what was quite interesting was that we could use the same training platform for planning purposes. And since I'm not receiving any warning, I think I have a little bit of time. One more minute? Okay, I'll finish it. So another interesting thing that we did with the same platform, as I was telling you, we wanted to develop different type of operator support systems, right? And we could never test these support systems on the actual construction site, mainly because of liability issues. The operators were like, okay, I trust you, I like you very much. You develop this prototype for me, but then if I screw up the asphalt, who is going to pay for it? So they would not ever, almost ever look at our data, and we could not actually assess it. And they would not look at it if they were kind enough. We had the stories where the operator decided to cut off the cable. In one instance, they threw the entire system out of the window. And then we used this training simulator actually to experiment with our ideas about different type of operator support systems, and then present it to them in a very safe environment that was actually without any major cost consequences. And we got very, very positive feedback from them. But also another application that we demonstrated for the same simulator, because it could be connected to the actual data, once the project is finished, you could dump all the project data into the simulator and see what you've done. So it's for project review purpose. Also, this tool was used in one or two occasions. So for future work, we have a lot of different plans, but the most importantly, we want to have more strategies about compaction, because 4 is definitely not representative of all the options that they have. Also developing strategies for optimizing the new compaction strategy. So for now, they have to choose one of the existing standard strategies, but you could potentially argue that by applying proper path planning algorithm that also captures the constraints, logical constraint of the operation, you could come up with some kind of unstandardized, unconventional strategies that could actually guarantee a better performance. So that's also something that we are currently working on. Thank you very much.
Thank you so much for a wonderful presentation. We have one quick question in the audience, perhaps. If not, we move quickly to the next one because we are a bit behind. One question? No? Plenty of time during dinner to reach out to you.
Yeah, sure.